was really doing while working at Blizzard, and was actually Pirate's superior while QA testing on Diablo 3. Now
Oh, he DQA tested on D3? You didn't even need to interview an employee. I could have told you he wasn't doing anything.
Whenever I scream about how I had to work with pirate software and how he doesn't know shit about fuck, I mean, I was directly ordered to deal with him for Diablo 3 testing in QA. I saw his PC screens since he sat in front of me. I had to assign, review, and redo his tasks.
He would just kind of create a character and idle in the client and redirect it. That's literally what he did. He sat in front of me and I was assigning the tasks.
Yeah, let me guess. He was assigned to the Wasps in Act 2, right? Yeah, bro, Thor fucked up.
I love the game, but man, it was bad.
Reddit all day, ignoring tasks.
Wait, so he was just on Reddit all day?
He was just browsing Reddit all day, ignoring tasks, and actively holding the team back.
But yeah, he definitely was assigned to Act 2. Oh my god. I knew it.
She and others tried to
Well, how did they manage to work there?
escalate the issue. The higher-ups basically said that they can't do anything about it because his dad was an executive of the company. But the worst part was when Jason ended up being Cynthia's roommates because apparently living with pirate software was such a nightmare that shortly after him moving in, her apartment was a disaster. She was asking him to leave early, and while cleaning up the mess that he left behind, Cynthia said that his walls were covered in either snot or some other gooey.
I had to clean everything by hand. There was, like, I don't know what on the walls in his bedroom. I don't know if it was snot or something else, just like white here and there on the walls.
He tried to mark his territory. The idea that there was a person that worked on QA for Diablo 3 that didn't do anything, that spent their entire time on Reddit and didn't do any of it.
To be fair, she's sus. I won't trust her completely.
White here and there on the walls.
He tried to mark his territory. The idea that there was a person that worked on QA for Diablo 3 that didn't do anything, that spent their entire time on Reddit and didn't do any other tasks. I don't need evidence for that. I already believe instantaneously. Yep, of course this is happening.
I didn't get this deep, stop feeding into it. All of the accounts that are messaging me are getting reported. There's a funny fact about this. I worked at Blizzard for 7 years. There's a whole lot of other people there that still know me, and all these reports are going directly to them. They're well aware of the situation, and everybody who's messaging me, they're going to get read. It's kind of a dumbass thing to do, and I can't wait for all to get banned.
Right. Did we do this? No. Okay. Wait, we did do all of this. This filter list map, yeah, okay. Write a function that returns a max or none if the list is empty. Some max. The max of the list. Then we write the max function. List max, yeah. I've already done that, right? Zip, okay. This doesn't feel like it's gonna work. Testing, testing. Testing, testing. I mean, the types are correct, at least. Wait, why the fuck did this work so easily? Why is OCaml easier than Python? Okay, let's try. Well, list of tuple. How the fuck would I make this in Python? No. Can I go L1, L2? I feel like this maybe works. Jesus Christ, my pie. Okay, let's just say it's Saint. Like this. Wait, this min len len. This is clean as fuck. So that would be like rexzip to L1, L2. How do you do this? Can you go like this? Wait, what? Oh, this only catches if both H2 and H1 exist. Okay. Hello. Oh, the anything else? Okay. What you working on? I'm just trying to learn OCaml. I'm not working on anything specific. I just got programming challenges from ChatGPT, and then I try to solve them. But yeah, I can recommend OCaml quite a lot, actually. So far. What does it do? This is just a zip function. So this is the implementation in Python. Basically take the shortest list and then you add each item to a tuple. So like, if you have two lists like this, it will return a list where first item are placed together, second and second item are placed together, and so on. Okay, I know Python pretty well. Yeah. But the cool thing, I don't know. The more I practice OCaml, the easier this becomes. Like, I don't know, let's try to make a mapping function in Python. So def map, we're taking a function and a list, and we want to apply, wait. They have a type of function. Yeah, okay. Okay. I don't know why it's... This is not... Okay. Okay, that wasn't that difficult actually. I think you just go like... F... list I... Fi for I in list. Well, I'll come on to begin with. I'm not sure actually. I'm going back and forth quite a lot on if I should bother learning it. There's some cases for it. For example, with Rust, an underrated reason to learn Rust is that there's a lot of very programming enthusiastic people using Rust. So the community is very good at building good programs. So it evolves. For Python, for example, the skill level of the people that program is a lot lower. So I think just by being interested in niche languages, you become a better programmer. And also, OCaml is very nice. So, in Python, for example, if you have a function, say def special function that takes in a list and an integer, okay? And we want to return both. I don't know how to do this. Can you not do this? Can you go like tuple? Okay, let's just pretend like this works. And you want to add an item to list. So list append, let's just say A, and then n plus equals 1. Then we'd return the list and then. Now, here this would be no problem, right? Let's see if we can disable pylons, maybe. Or no, I mean, I'm not sure how to disable MyPy. But this would be no problem. But when you get large programs, and let's say this is like called, I don't know, amount of items or something. This is n size. Then it's more arbitrary what type there are. So you could have problems that you try to n size append and amount of items plus equals 1. So, my point is also, I would catch this, but if you just write it without MyPy, then my MyPy and Vim as well. Oh, there we go. You wouldn't get error. Because this is legal Python, right? Even though this will be... This has to be a list for a function to work. No, this has to be like integer or float for the list to work, and this has to be a list, right? So in Python you have to enforce that by saying that this is a list, and so on. In a strongly typed language like OCaml, this happens automatically. So if you make a mistake like this, that this is, say, this would just break the program, this wouldn't work. So the function knows it doesn't work before you do anything. And when you write like, I don't know, larger functions like this, to just know that the function works correctly, that it takes in an alpha list and returns a boolean. It's kind of nice. I have those two reasons at least. And to be fair, it's very quick as well. So it's almost as quick as C. Is your day job? Just curious. I don't have a job. I'm a student. Okay. So yeah. So like a filter function. In OCaml, do you know what linked lists are? You basically have like an object as in Python. That's also an integer. Okay. But what was going to do? Yeah. Okay. You have an object that holds a pointer. I thought it would just work. Can you not do it inside? Really? Okay, pretend like it works. There are no pointers in Python though. Yeah, but no, not. So that's one reason it wouldn't work. So the whole architecture of Python wouldn't allow for what I'm trying to show. Okay. Anyways, so for example, to get the length of a list in OCaml, lists are made out of linked lists. So to add to a list, you would prepend. You would add an item in front of the list. So if you have a list of 1, 2, you would add to the list by prepending like this. I think so this would add in front. So but in Python, if you add to a list, you add behind, right? So append. Because it's a data structure. It's just a place in memory, every item after. It might not even be that in Python. In C at least, just have like a type and a place location in memory, and then every item is followed. So appending to a list in C or in Python, you might run out of locations in that spot, so you have to resize sometimes when you increase the size of an array. So it can be very slow. In OCaml it's a linked list, so it's instant. It's over 1. But something like getting the length of the list in OCaml, that's OON, because you have to walk through the whole list and count. In Python, you know the... Why is it O1 in Python? Is it O1 in Python? Maybe, I thought it was O1. Yeah. Because, why is it O1? I guess since you know the size of the memory address, I guess, or how long it. I'm not entirely sure why it's over 1. Like this makes sense to me, right? Because what he's saying is that if you have a table, right? You know that Python knows the length of the table. But also the list is only like 3 items long, and it hasn't filled out the rest of the table. You all want to know the length of the table. Because But how would it know how many items are in the table? I don't know. But at least... So, different architectures for the language will make some parts faster and some parts slower. So prepending to a list in Python, you will have to move the entire list in memory, right? So that's very slow. But appending to a list in Python is not very slow because you know the location you need. Okay. Write a function that unzips a list of tuples. Okay. So for example, this is a good example. This is a tuple in OCaml. So now I know, not by knowing anything, right? I don't know how to do this. But I know that if I write it like this, then it accepts an A-list. If I write it like this, it unpacks like a tuple. So know that this is the correct way to write this function. And it might even be something like this. No. No. I think it works. This just feels like a bad way of doing it to begin with. If we go like T1, T2, would this be? I'm having trouble understanding this. I'm not seeing it. Since unzip will return a tuple of alpha list and beta list. So at the top recursion, I don't know how to say it. We will return the result, right? But we sort of need the result of all the following recurs. Jesus fucking Christ. Recurs.
Recursion.
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 Recursion. Which is returning a result. And we want to basically return that result from the inner recursions. Recursive recursion. So here we're basically, if h1, h2, return the result of the first and second. Does everything work? Yeah. Or is it moved to the left?
Variable declarations in OCaml bind variables within a scope, the part of the program where the variable stands for the value it is bound to. For example, when we write let x equals e1 in e2, the scope of the identifier x is the expression e2. Within that scope, the identifier x stands for whatever value v the expression e1 evaluated to. Since x equals v, OCaml evaluates the let expression by rewriting it to e2, but with the value v substituted for the occurrences of x. For example, the expression let x equals 2 in x plus 3 is evaluated to 2 plus 3, and then arithmetic is used to obtain the result value 5. Functions also bind variables. When we write a function definition in OCaml, we introduce new variables for the function name and for function arguments. For example, in this expression, two variables are...
I'm gonna make lunch. Egg and ham sandwich. Let's fucking go. And a coffee. And the white monster. Holy shit.
So, this morning I woke up and there was a video online from RustConf 2018, which I didn't know was a thing, but that's a thing, where they talk about Rust, the programming language, not the game. And there was a video on there called Using Rust for Game Development by Catherine West from Chucklefish. And I watched it, and I have some disagreements with it that I'm going to want to talk about today. They're not... they're not internet flame debate caliber disagreements. Some of them people might think are pretty subtle, but they're important because they get down to the foundations of how do you want to program and how do you make sure your program is correct. And, if you're designing a programming language, how does the programming language help you know that your program is correct and all these things, right? And so I just wanted to go through and hit the major points of what I disagree with. I'll say, in the beginning, so that people don't get the wrong idea, I think that overall it's a good talk and that people would learn from watching it. It's just, there's just some things.
I recently watched a Jonathan Blow video. I think it's his newest, where he talked about a trick that was very cool. Also, why the fuck doesn't this work? Can I go like... Can I enforce that the function return type is an int? Python parameter function type return. Python. I actually kind of like that. I guess we'll just do this. So this is callable of type int. Right. Callable of type int and return type int. There we go. So this is a type of a callable function with an input and return maybe. You see how this is a lot like just painful in Python, whereas in OCaml, you don't need to care about this, right? Because there's only one solution to the problem, and I don't even this would work for any list, right? In Python I can't guarantee that, because this function might do something. Here the function, basically the requirement for me to use this map is that this function is valid. And that it gathers that automatically, right? I wonder what, like, list map, can I go like... map function... I don't fucking know. Yeah, look at this. Look at this. It needs... like, this is why Python is bad, because when you actually need it for stuff, or bad for advanced cases, you end up with stuff like this, right? And I would even bet almost that we probably have like a list map, yeah. Let's look at this thing. It's like a whole different world, you know? If it's empty, return. If there's one item, you return the list with that one item. Else you have, I don't know what this is. Maybe this is item 1, item 2 and the rest. The tail. Like, are you seeing this? There might be more to the story, right? Are you seeing this? This is the same as this. You need to check system version. Else. New, you need a callable type, right? And I need to populate that with some... I don't know, fucking know. And that will like decide maybe which of these... I don't even know what... like, this is advanced stuff, you know?
That I got to talk about. So let me.
Yeah, my bad. Okay. So anyways, let's say you have a big program and you made your own mapping function, okay? And you wonder, there might be an error in this function, but you don't want to change the whole program for every use case, or every case is used, right? So you can make like a new map, which is a different map for our use case, but let's just say this calls F2 instead. A different function. And you call this all map. And then you write a map function that takes in this, basically the same thing, but instead it will assert that old map f list and new map f list Wait, how do you sort? Do you like this? Sort at the and then you return the new map or old map or whatever. Right? Because then you check that like the functions has to return the same value. They have to work the same. And then you know if this fails, that the old function was wrong or the new function is wrong. And you don't need to change anything else about the program, because the name, right, is... You just change the old name to the new name. This was like... This is brilliant. I wonder if this does what I think it does.
I'm going to bring the video up for a second. Oh, wait, I can do that? I can toggle. Let's just do this. Okay. So we're going to watch about a minute-long excerpt from it and hope that I don't get banned for showing a video. And we'll just use that as a starting point. But before we even do that, let me say, why do I care about this, right? So Rust is a programming language that I think has more of a reason to exist than most new programming languages, right? Like a lot of new languages are made by people who just are making essentially small stylistic changes to things that already existed, right? And small stylistic changes, in the best case, could reduce friction and make things better, but usually they're just randomizations that don't make anything better. And they don't really solve real problems usually, right? So what Rust is trying to do is it's trying to increase software quality overall while, I'm trying to figure out the most charitable way to say it. I mean, by forcing the programmer to do things in specific ways overall, while, I'm trying to figure out the most charitable way to say it. I mean, by forcing the programmer to do things in specific ways that are supposedly more safe, right? And I'll say supposedly because this is going to be important later. And how does it do that? Well, and without taking a big performance hit for that, right? So a lot of languages that are predicated on the idea that memory safety is very important are garbage collected languages that like don't let you poke at memory, and Rust doesn't do that, right? So it's more in the direction of things that I think are a good idea, where instead of having memory be managed for you, it's just, there's like a permissions model. There's a statically analyzed or compile time enforced permissions model that determines what you can do with various pieces of memory and what you can't. And it is by nature overly restrictive. So there are some things that you could do that are correct that it won't let you do because it can't prove that they're correct, right? And so that's the basic idea behind what that language is doing. And part of the thesis of this talk is like, well, at first you have a hard time dealing with that stuff, like the borrow checker in Rust, you fight the borrow checker and it's very frustrating, but it's good because it then pushes you into patterns that are better anyway. And part of this talk argues that object-oriented design is not very good, and then this other thing is better. I certainly don't disagree that object-oriented design is not very good. Most people with a clue these days pretty much have done enough programming in that way to see the way it's bad and the way that it doesn't work. So I'm not, I have no argument with any of that. And in fact, the first disagreement that I have with this talk is something kind of subtle. So let's just talk about that for a little bit. Let me make sure my desktop audio is all the way up, and I'm going to be quiet, and we're gonna listen for a second.
Our internal states. I have this. I'm going to use this a lot, and this is going to end up being important. But there's this entity index type, And this is actually really interesting because this is super common in C++ game engine. In fact, I've never seen a systems programming language kind of game engine that doesn't have these. And this is a C++ example. So you might think like, okay, well this field is player ID. So like, Starbucks is a multiplayer game. You need to keep a list of all the entities that are a player. But why don't you use a pointer? It's C++. We can live dangerously. Let's keep a pointer. And the thing is that nobody does this because it's wildly unsafe. If you keep internal pointers, they will become invalidated and your game will crash. So nobody in the systems game development environment, all game engines have this. It's either an ID or some kind of index or something to identify entities. And this is important because we have to do this in a lot of places in Rust, but it's the best idea. And it has other benefits like, for network serialization and file serialization. It's hard to serialize a pointer, right?
Okay, so let's start talking about that. It's completely correct what she says, that this is a pattern. Well, I haven't done a survey of all game engines in the world anytime lately, but what she described is basically the way that I do it, and probably the way that nearly everybody does it. And in case you don't program game engines, which I assume most people on the stream don't, I'm going to explain in a little bit more detail the problem that she's talking about, right? So the problem is that in games, oh yeah, I guess I could enlarge the webcam since I'm mostly just talking. I don't want to be too big. Okay, we're going to be. Let me just. I'll put myself up here in a contentious place, so that. Wait, what just happened? All right, so. You can still look at this code. What I'm saying is not going to have much to do with this code because I think there's other things. There's some things that are misleading about this code that is shown here, but anyway, the basic issue with game engines that happens in all games is that entities want to be able to refer to other entities, but entities are also transient, right? So let's say you have a game full of little people and one person wants to follow another person around. Like there's some piece of code that's like, or there's some script trigger that says this makes person A follow person B. So person A has to have some kind of reference to person B about who that is. And then maybe every frame person A runs their update code and says, am I following someone? If so, then get the vector from my position to their position and so forth, right? So that's very, very common. Okay, and so what she's describing is the following scenario. So person A gets, let's say you do this the naive C++ way, where person A is an object and you created it with new, and so is person B. And then on person A, when you say who am I following, you have a pointer to person B, right? And we'll talk about what the modern C++ people would say about this in a minute. But that's the naive C++ way, like every year that you would do it until 2015. And well, the problem is, of course, that person B could, just get destroyed for whatever reason. He walks into a teleporter and disappears out of the universe. Gets blown up or something, or replaced by something else. So when that happens, the default thing in C++ is just that person A doesn't know that person B got deleted, and person B's memory no longer exists. So then person A comes along to run its update function, and it says, let me follow person B, and let me go look for the direction vector, right? Or get the direction vector between B's position and my position, right? Now B may just have been freed and still have the same memory that it had because nobody's reused that memory. The memory could be reused by an arbitrarily different object, however, right? So when you go to read the position of B, you could get garbage bytes back in the form of floating point numbers and then be doing math on like some garbage numbers or some nans and get a really terrible result, right? Possibly even worse, or maybe not quite worse, for reasons we'll talk about later. The memory could even have been unmapped by the operating system. Like, oh, we freed this, and that was the last part of this one page that's been used, and now the page is no longer needed, so we're going to deallocate that physical page and so forth. And then if you try to reference B's position, you just get a page segmentation violation, right, and your program crashes. So just like you would if you were dereferencing a null pointer, right? So that's really not good, and it feels really bad for that to happen. It's a really ugly kind of a bug because your whole program just dies for what seems like a small mistake, and it's even more ugly because often in release builds you might not see this bug for a while, right? Because maybe that memory is still valid because nobody's reused it yet, and then maybe it takes a long time to trace from the symptom of the problem all the way back to the actual cause of the problem, because the cause of the problem is that B got deallocated a long time ago and it's so far removed, right? Now the modern C++ people would of course say like, oh, use a smart pointer, you should never use a raw pointer or something, but that's actually naive for several reasons. One reason is you don't want to use a regular reference counted pointer, because you're not, like, person A is not authorized to keep B alive, right? So like keeping B alive with a non-zero reference count is also a bug. That will be hard to trace down in many cases. And then, well, there's other things you can do. We're going to talk about one of the other options in a minute. Anyway, so what she says is everybody does it this way, where you have an index. So what she's saying is everybody, instead of having a direct pointer, has a system where you have some kind of small and inexpensive identifier for an entity. For example, an integer index. That's what we had in Braid and the Witness. Every entity was just an integer, right? In one of the new games, it's actually two integers bitwise ORed together, but it's the same thing. It's essentially an integer. And that's a cheap thing. It's easy to copy. It's easy to look up in a hash table or an array. And then if person, so then every frame person A says, hey, entity management system, give me back the pointer to the entity with the ID of B that I stored when I started following B. And the entity management system will either say, okay, here's the pointer, or it'll say, no, it's gone, right? Now, when A looks up B and the core system says, no, it's gone, because A knew that it was mapping from an integer to a pointer, and because it knows that that mapping might fail sometimes, the code there will naturally handle this case. So you won't, in general, make very many errors that way. And that's why basically everybody does it this way. I think she implies in this minute of speech that we just viewed that that's the only way to do it. It's not really the only way to do it. So there are two other ways this morning that I thought of to do it, one of which I tried in the past, and another one which I never tried, but which I'll explain. Because back when I started a game company in 1996 and we were building a game engine, we had exactly the same problem. I had to learn my way through what is the best way to do it, and we had to try several solutions, right? So another solution to this problem, aside from looking up an integer index all the time, which you might not want to do because it's expensive, right? Or seems expensive. It's not really, especially, well, I don't know. It's less expensive than some other options. But one alternative that you could do is, well, instead of just deleting B and freeing the memory right there when B gets destroyed, then maybe B lives for an extra frame and is flagged so that it's flagged, B has been destroyed, but the memory is still valid, right? So then you could still have a pointer to B on A, and then A's job every frame when it checks, when it does something with B, its job is to check to see if B has been destroyed, right? And if so, then nullify its pointer, right? In principle, that's faster. In principle, it's simpler, but it's actually slower and more error prone, right? So the reason it's slower is because if B only lives for one extra frame or n extra frames, then any entity that has a pointer to B has to check and possibly clear that pointer within that remainder time that B is alive and says that it's been killed, right? So if that's one frame, then every entity has to run its update every frame to check to see if the guy it's following has gone away. And the more entities you have in the world, the slower that is, the worse it is. You don't want, so you might think, oh, just a simple update function for an entity, if that's all it does in the fast case is check one pointer, isn't that really fast? And it's like, not really, because the memory for most of these entities is cold. You're like visiting the entity. You have to get its memory into cache before you can even run its update function, and that ends up being one of the slowest parts, right? So in a relatively non-dynamic game like The Witness, where most of the entities are static, at the beginning of development, the theory was, well, we can just let all these entities update every frame and we won't have to worry about it because there aren't that many dynamic entities. Well, by the end of the game, about a year before ship, I had to write a system where entities would sleep, and not run their update function until they get woken up by something, simply because it mattered that we were running updates on, however many. It was a small single-digit thousand number of entities, right? But that was too much, especially on game consoles, which had which perform worse under conditions of large volumes of random access to memory than PCs do, right? So that is one alternative solution that you might think of. Okay, so that's the reason why it's slower. The reason why it's error prone is just, if you've got a pointer to an entity on your entity, you might just forget to check if it's killed, right? Because why would you remember that? There's no explicit step that reminds you. When you have to map from an integer to a pointer, that mapping is the explicit step that reminds you that the pointer you get back might not be good. But if you're just going to use a random pointer that's like on a member, it's very easy to forget to check, right? And then you have the same fail state. You have the same problem where the memory is deallocated and you don't know why. Like the symptoms of that solution are not any better. And that's why I think nobody really does it. Those two things together, right? The third thing you could do is some kind of a weak pointer system, right? Where on A, you say, okay, I'm following B. I have a weak pointer to B. And I can start just using that pointer arbitrarily, but I have to check to see if it's been nullified by an external system, right? So a weak pointer is something that'll turn null later, but it's not my job to turn it null. It's the core system's job to turn it null, right? And so what does that look like when you program that? Well, you know, the system has to know who is pointing at B, and that could be a large number of people potentially, so there has to be some arbitrary amount of dynamically growing storage that stores pointers back to people who point at B, right? And you have to go nullify all those guys, right, when B goes away. But then, you know, the guy who was pointing at B might go away first. So then you have this accounting in that direction of removing his pointer from the weak pointer list if it's no longer needed, etc. That gets complicated, and that has performance implications, right? And I think something along those lines is what the modern C++ people would advocate these days. I don't know exactly which std : whatever they would say is the right solution to that, because I just don't follow any of that stuff. But it would be something in that direction, right? Well, there are two problems, right? One problem is it's less performant and it's more complicated. And even if you didn't write the code, that code in that memory is still happening all the time. And that complication is in your system and you will have to deal with it, right? So that's thing number one. Thing number two is, again, there's this ambiguity. Like when you start, if it's a totally transparent weak pointer, if it's one that you can just like use and then maybe you have to check it for null once, that's a little confusing. Like, when can it be null? I mean, I guess it can be null only at the end of each frame, but if I have a bunch of methods on my entity, I guess I have to check it every time or at the head of each method, because I don't know which ones are going to get called from what entry point, especially as my code gets refactored. And I might forget to check it for null because, again, there's no signal that I should check. There's no step that reminds me that I have to check, right? And so I'm going to forget to check. So then what happens? Well, I'm designing this weak pointer system, and I want to ensure that people don't forget to check. So, well, what do? You have a getter on the weak pointer. The weak pointer itself is not something you could directly use. You call like get pointer value on it, and that gives you a pointer that you can use for the body of your procedure, and you better not store it in a data structure because you're a bad citizen if you do that. Okay, by the time you do that though, the access pattern in code looks exactly like this one here, except it's got all the added internal complication of this weak pointer system that this one doesn't need to have. So in general, you know, the version that Catherine is saying everybody does, I think most people do. I think some people do a weak pointer version. I've heard of that being used, but I don't think that's very popular because it doesn't really have any advantages. So she's very correctly saying the right thing here, which is like everybody does this. It's the right way to do it, okay? However, now we get to what I disagree with. So what she says, I'm gonna paraphrase, but she says that nobody uses the pointers because the pointers are very unsafe and will get invalidated, right? What they're pointing to will no longer be the right information and you'll crash, okay? That is correct. But my problem is that that's not actually the problem. That's not actually the bug in the program. It's a symptom of the problem in the program, right? And this may seem like semantic nitpicking, but it's important. I'll try my best to explain why it's important, right? So the symptom is, hey, I've got a pointer and it doesn't map to anything valid anymore, but not necessarily consistently, because sometimes the memory happens to have the right content still, and it's really hard to debug and wastes a lot of my time. Okay, great. Not great, but yes, accurate. Okay, but the real problem is...
I'm gonna try something. I wonder how we'd comment this out. have to zoom in. Hello. Would that not be correct? Maybe it's a large J? Like this? Closing bracket expected near J. May I ask something? Of course, of course. Turn these brackets around. Thanks, I'm a struggling developer. I started like 3 weeks ago. Do you have any advice? Yeah, focus on enjoying and focus on putting in hours. I've yet to find a better predictor if someone's good at programming than how many hours they've spent programming. And also try to like trick yourself into enjoying it. So don't do projects you're not interested in. If you want to make something or like have something you it's good though for like game making, you mean? I guess if you're making games, try to make something you are passionate for. That will make it easier to work. Yeah, those are the main ones. I don't know. One thing that helped me quite a lot is actually just watching streamers. So this guy, I've watched like a decent amount of, and also this Jon, is it this guy? Yeah, this guy. They're just like really good developers, right? I mean, what about learning too? No, but the key is that you
Good with logs.
You don't know what you don't know, you know. So when if you watch streamers or videos of people working, you can see their thought process and what tools they use, and then you can research those tools and apply it for yourself, right? So it basically increases the ceiling you're able to get to. Like if you just work on projects, you're gonna sort of plateau. You maybe gonna try something difficult and then you will have to do it and then learn a bit more, but you will quickly plateau. To move that ceiling upwards, watching streamers is a good way of like learning what what's out there, you know. Yeah, those are the main ones, I think. I like that.
That for the system to be correct, work has to be done in some fashion to coordinate the fact that entities can be destroyed with the fact that
I see. Black for learning as a total beginner. Should instantly go over to streamer, you mean? No. You should try to make projects. I don't know how beginner you are. If you're very, very early on, maybe watch tutorials and try to do the programming challenges. But also, like, just spending time on it is the most important, and also being interested. Like, to underline that, I think if I have 2 people I want to help learn to program, I can make like a perfect schedule, like a student, where you have to go through these topics and make these projects and learn this, and the other student gets nothing. I just tell them to program. If the student that doesn't get any feedback or any help programs 100 hours, and the student that gets help programs maybe 50 hours, I would bet my money on that the student that hasn't had any help or any path or any learning objectives will still be better just by having put in more hours. Thanks for advice. I really appreciate you giving me advices. I'll try to work upon your advices. Yeah. Good luck.
people want to refer to other entities, right? That cross-referencing has to correctly happen. When that doesn't correctly happen, that's the bug. And then the symptoms of the bug will vary depending on which solution you do, right? So for the transparent weak pointer version, the symptom of the bug, well, it's slightly different bugs every time. But for the raw C++ pointer version, she's talking about the symptom is probably a crash or some kind of Heisenbug, right? And the reason this solution she's talking about is preferable is that it happens to be the simple solution that doesn't really provide an opportunity to fail to do that coordination, right? Because you have to do that coordination. The act of looking up this ID is the act of doing that coordination, right? And so again, the problem is a coordination problem. The symptoms of the bug will be different depending on the implementation. So another possible symptom, if you do the weird solution I was talking about that nobody really does, where entities hang around for extra frames, no, let's not talk about that one. If you do the solution, the naive modern C++ solution that I briefly mentioned, where like, hey, you just have smart pointers, right? Then the bug that's going to happen is going to be different, right? So A is going to have a smart pointer to B. It's going to be like a shared smart pointer. And then the system is going to have a shared smart pointer. And the system dereferences or reduces the reference count on B, but A doesn't. And now there's kind of a leak accompanied by this weird situation that A thinks B is still live when B is not live, right? So that's a different symptom of the same core problem, that the coordination was not done correctly, right? You might say that that symptom is better because you don't crash necessarily, although you probably will crash as those bugs pile up and the behavior of your system becomes weirder and weirder, right? Oh, and also it's the reason I hinted at the beginning is that maybe it's not so bad to have a crash, is that crashes at least signal to you very clearly that there's a problem, during development anyway. Like, you hope that they don't make it into release, right? And so crashes actually save you time a lot of the time. If you have a good enough programming culture that you don't ship builds to the content people that have a lot of crashes in them, right? Worse than a crash is a silent failure that's going to corrupt your behavior of your game, or data on disk for like weeks before anybody notices that the data on disk is subtly wrong in places, right? That's really horrible. And that's what happens if you don't crash, right? So crashes are not necessarily as bad as you think. Okay. So we're not going to watch any more excerpts from this. You can go watch the whole talk if you are so motivated. It's about 40 minutes long. But she eventually goes on. So one of the theses behind the talk is, look, the Rust borrow checker is good because it forces me to lay things out in this data-oriented way where, you know, I've got components in arrays and so forth. And I'm going to skip commenting on entity component system. I don't like entity component systems. Whatever. If you like them, fine. Not the subject of this rant. But the solution that she ends up advocating is, you know, I forget what they're called in Rust, VEC, I guess, which is annoying. They inherited bad C++ nomenclature, but VEC, as far as I understand, is an automatically expanding array, you know, that you can put stuff in and it'll get bigger. Like, everybody uses those today in modern programming. It's a workhorse of programming, right? And what she says is, well, look, you've got all these components that primarily consist of data, and you'll have an array of physics components and an array of humanoid state components and whatever else, and you just, it's like what I used to call a refrigerator. I don't know if people call it that anymore. Maybe they call this a pool. I don't know. Names for this change, but because all the elements, it's basically an array of memory, and because all the things that you're allocating and deallocating there are the same size, then memory allocation becomes almost trivial, right? And so she says, hey, just have an array of these components, and then we're going to use this generational index thing to determine if the slot that you're looking at is the one you meant to or not, which is actually almost another way of solving that entity coordination problem that we talked about, which is kind of interesting. Okay. But what she says also is, hey, when you're doing this, the reason you need this generational index is because you could accidentally be pointing at the old thing, right? And it's safe because it's memory that is valid, but it could be old, right? It could be stale. It could refer to an entity that's no longer live. Now, she's saying all this stuff from a very Rust point of view, right? So she said, in the part that we watched, she said, oh, it's unsafe to have these pointers here because you could crash or because you could reference memory that doesn't exist, right? Or you could reference memory that's not the right memory and corrupt some other part of your program. And she says, oh, this array version is safe, but it's not really any safer. Because here's the funny thing, is she's saying that the borrow checker forced her into much safer programming. But what she ended up doing is actually implemented her own memory allocators as these vectors of data structures. And then the reason why Rust isn't giving her a big argument about what she's doing with them is because the Rust compiler doesn't know that those are memory allocators. So there's no borrow checker activity on them, right? So it's this weird thing where it's like, it seems like a little bit of Stockholm syndrome to me, where it's like, oh, the borrow checker is so good because it made me program in this certain pattern, but then the real reason that the borrow checker is not complaining anymore is just that I managed to turn it off, but I didn't realize that that's what I did, right? This thing, Let me see if she has a slide later. I don't remember at what minute she gets a little too factory here, but there's a place where she talks about this. Yeah. So she's like, hey, my game state is going to have just a bunch of these arrays of all these things, right? Of each component type. Well, this is basically a custom memory arena that, or arena might mean the wrong thing depending on where you come from, but a custom memory allocator where, you know, there's either a physics component or not in every one of these slots, right? Now, why does that seem safer? Well, first of all, because the memory is never going to unmap, because the whole vector is, or vec, it's not a vector. The whole vec is not going to shrink, probably. I mean, I don't know why you would make it shrink. I can sort of imagine why, but you probably wouldn't make it shrink. And so therefore, you are guaranteed to be referencing memory that exists. But that memory is not going to be correct if you make a mistake, right? And that is exactly the kind of thing that the borrow checker is supposed to avoid. Now, I said earlier, I said this is going to sound nitpicky, but it's actually not. That there's a difference between the actual problem and the symptom, right? And this is where this is important, because the actual problem here is the same. You actually just kick the can down the road. The problem is still, I might have an allocation and somebody pointing to it, and that somebody might not correctly check the thing if they don't do it quite right, okay? The symptoms, however, are less dramatic. And the reason, though, is not really anything architectural, right? So this is the core thing that bothers me about this talk is she says, hey, you know, the borrow checker pushed me into this architecturally better thing. And I don't think it's better. Like, the reason the symptoms of the problem are not as bad anymore is just that you've refactored your allocations so that you're storing everything of the same type. So, you know, the reason sometimes that things get ugly if you reuse memory accidentally in the wrong way is that, you know, earlier there was a floating point number in this slot, there was a pointer in this slot, but that memory's been freed, and now some floating point numbers got wrote there instead, but I still think it's a pointer, so I'm going to read that pointer and try to use it, and I'm going to crash, and that's a very ugly seeming thing. Although, as I said, crashes are maybe not as bad as you think. Well, that doesn't happen here, but it's not because you're architecturally better, it's just because you removed one physics component and you put another one there, and they're the same type. So the pointer slots go into the same pointer slots, and the floats go to the same floats, and the bools go to the same bools. So you don't have that kind of data misalignment problem. So it seems less ugly, but the problem is still there. It's still there. Now, in the process of doing all this, you know, in this version of Entity Component System, she formalized a way of referencing these things where you use that generational index, and that's a pattern that avoids this kind of a reference, right? But the data storage is not really the architecturally better thing. It's that pattern of I know I'm using a certain index type to check the thing, and that index type will tell me whether it's still valid or not, right? Now, the reason that doesn't happen on a general heap as easily is because on a general heap, allocations are not really the same size. So like, you can't look at the first byte of the allocated block or the byte before it or however it's implemented or a parallel array. You can't look at that and ask what generation is this or something, because you don't know if that's the first byte in the block, because the sizes shift around inside a general heap, right? So the fact that these things are all the same size makes it possible to do that generational index thing. But what I'm trying to get at is that the borrow checker didn't help her solve the memory allocation problem, really. It made her kick the can down the road to the point where the borrow checker got confused and couldn't tell that she's allocating memory herself, right? And so she turned off the borrow checker manually and then made her own system that tries to make it not error prone, right? And so it's hard for me, in the speech, she credits the borrow checker as being really beneficial. It's hard for me to see that it's beneficial when really what you're doing is finding a convoluted way to turn it off and then doing a pattern that you would do in any other programming language. All right. So I'm starting to rant and repeat myself at this point. Let me look at my notes for a second to see. Well, I've been ranting the whole time, but I've been starting to repeat myself. So I think I've said everything that I want to say. So again, I don't want to come across as too critical of this talk. When people implement new systems and new programming languages, it's a good thing. Rust being a very a programming language that has a strong, well-understood philosophy about what it's trying to do is a good thing, right? Of course, I'm designing a language that's different from Rust. I disagree with the overall goals of Rust as being the right thing for game development, which is why this is on my mind. But one reason why I'm looking at things like this is I want to know, like, even though I don't want to program using the borrow checker, at least not most of the time, maybe I would like an optional borrow checker to turn on sometimes, but I'm not sure that that's possible. Even though I disagree that that's the right trade-off to make in terms of, where you put your effort when programming. I still want to know, okay, if I'm going to say that a good language design in 2018 for games doesn't have a borrow checker, then if I'm going to be a good engineer, I have to know the cost-benefit analysis of that decision, right? Whatever is good about the borrow checker, I should at least be vaguely aware of that I'm giving that thing up in order to do a design that doesn't have that, right? And so that's what I'm doing, is I'm just watching this and I'm trying to think very critically here. What is she really getting out of that borrow checker? And in this case, I actually am not seeing concrete architectural benefit. Not very much. Now, it could be good in the fact that, like, hey, it just forced me to explore and do something differently than I would have otherwise. But, and again, maybe my entire rant here is wrong, and there's some reason why this is actually correct and doesn't just amount to turning the borrow checker off invisibly. But I'm pretty sure it is. I'm pretty sure it's just turning off the borrow checker invisibly, fooling the compiler. And so, okay, you could make the following philosophical argument, that it's not really fooling the compiler, because even when something in this array is deallocated, it's still a type-safe interaction, because you know that whatever data filled that slot was that type. It's just stale, wrong data, right? You can make that argument. Maybe there's something to that. Again, it may not all be positive, because like I said, having a strong symptom like a crash is often good, right? It helps you. So, yeah, maybe somebody from the Rust community wants to tell me why they think this is really good. I can see a little bit of a case for it, but it doesn't seem like a very strong case to me. It doesn't seem like a case that's so good that I want to spend that much time and effort, convincing the borrow checker that my program is good. But again, I could be wrong. So I'm not trying to flame war this. I'm not trying to say, oh, these people don't know what they're talking about. I'm just trying to put my opinion out there in response to this thing that I saw, and we'll see. I mean, maybe I would be happy if somebody could come back to me and say, no, this is not really just turning off the borrow checker because, etc. And then I would really learn something. I think I just learned a little bit in the fact that I had to think about the nuance between, this thing is a deallocated version of a different thing of the same type versus its data of any type. There is a difference there, right? I'm not sure it's an ultimately very meaningful difference, but it is a difference to understand and be clear about. Okay, so that's the rant portion of tonight's stream. Does that make sense? Do people have questions about that? Phil Trudeau, how do you map entity IDs to pointers in a simple way other than generational indexes? Do you binary search an array of entities? In the witness, it's literally just an array index. I think it's actually an array index plus 1 for some stupid reason. like we literally just subscript the entity array by that number. I think that's the way it works in Unity for components as well. It's just an array index. I don't know Unity that well, so correct me if I'm wrong there. There are other ways to do it. So in the Sokoban game, it's actually a hash table, and that's because our indices, like I said, we're ORing two things together. Our integer ID in Sokoban is like a user ID in the top 8 or 10 bits, and then an entity serial number within that level in the bottom remainder of the bits. It's 32 bits total, so the bottom 22 bits. So you don't want to make an array of those because that'll be a really big array, right? Because the high bits are set. So we use a hash table for that. Devender says, I stand by what I said earlier. It's like saying that the GC is good because it encouraged you to dodge the GC. Yeah, maybe. I mean, definitely with the GC version of that argument, that is clearly to me full-on Stockholm Syndrome, like 99% of the time. In this case, I'm not sure because I don't understand the Rust borrow checker case as well. Like I've programmed in garbage collected languages. I've implemented garbage collected languages, right? I know some things about garbage collectors. I've implemented different garbage collectors of different types, right? I've never implemented a borrow checker system or a static analysis system that's that hardcore, so I don't have as clear of a picture into that. And I haven't programmed in Rust, really, aside from super trivial Hello World programs. So I cannot claim as much visibility into that. But it did, while I was ranting, I did think of the GC analogy that you mentioned as well. Newbie says you can also zero on dialog and crash with error message of that type. Oh, totally. Like, well, in Visual C++, for example, the default or the debug version of the heap, when you call free, will overwrite the memory with oxcd, which is never going to give you a valid pointer. And so it makes things crash very easily. Or if you get wacky numbers because you're referencing scalars, you look at them in the debugger and you say, oh, that's oxcd, it's a cleared memory. Now, the hard part from there is to know who freed the memory and when, and then to understand why that happened. But and the real problem there is that all the tools that people made to help with that are not necessarily very good. Although maybe ASAN now and LLVM is good. I don't know. I haven't used it in a long time. But usually all the stuff like Purify in principle was a really good way to find that kind of a bug. But it lost its focus on C++ and it became like a managed language thing and got slower and slower and more horrible, and it's kind of unusable now. But like with a good tooling, it wouldn't be such a hard problem either.
All right. Okay. Back to work. Wait, is this a... X is equal to E1 in E2, and then we put that into the function f. The scope of the variable f is the body of the let E2. So this is sort of... So X and Y, I'm guessing you can't use outside here. Cool, okay. Okay, so these are sort of variables you can only use in this expression. Okay. To declare a recursive function, the function must be in scope within its own body. In OCaml, this requires using a let rec instead of a let. With let rec, every variable it declares is in the scope within its own definition and within the definition of all the other variables. Is it just me or was it very loud outside today? To make this work, all the definitions that use these variables must be functions. For example, here's how we could define mutually recursive functions even and odd. This is tricky. I think it's saying if x is equal to 0, this is true, so x is true, which means even is true. Or if it's odd, x is false, so even is false. Maybe. Odd is true if this is false. This is false if either this is false or this is false. This is of course false. This is defined. So if it's not even, if the previous number was not even, Jesus Christ. If the previous number is even, that means the current number is not even, which makes this true, so not true is false, so odd is false. Holy shit, why the fuck is it? This is not integrate way to write this. No? That's insane way to write. There's no way this is the best way of doing it. I think this is just wrong, you know? Oh, I see the problem. Okay. Okay. Since age 2 can still be greater than age 1. The item after age 1 in that first list, right? Mm. Why does that work? Why don't we need this? Oh, that makes sense. Since this here basically means that when both are empty, we're done. Wait. No, I don't think this works. Because this is saying either the second one is empty or the first one is empty. Return the opposite. Wait, is the OR operator like if this is false, then this expression is also false and will not run? Why is it skipping? If head and tail means head is a list, right? This makes sense, right? I want to check something. Pattern matching OCaml. If it's normal to have it like this or like this, basically. Oh. Damn. Hair matches. It looks like the most common is yeah, okay. So let's start using that. Yeah, like this, basically. No, he does it like this. I disagree. This makes sense to me, and this makes sense to me. So like, we're taking the... Okay, I agree. I like it like this. So basically, this would be one out. This, everything would be one out. Function is one out, match the same. Okay. Okay. The types looks correct, at least. It's not. This means it has a head. If it doesn't have a head, if the head what? Maybe it's like Whew, damn, I don't know. No. This should be an H. Since the head is the list. And for item in the list, if we're at the end of the list, return the list maybe. If there's a head and a tail. Take that head and flatten that tail. Yes, that makes sense. Yeah, I think I need to rethink this. Wait, is this like alpha list? Yep. Let aux accumulate list accumulate equal basically in
It's been said that computer science is the science of abstraction, or perhaps efficient abstractions. What is an abstraction? Well, as a verb, to abstract here means to forget information, with the purpose of being able to treat related things as being the same. That is, you're forgetting about the details that aren't important, and focusing on what is important, what the common pieces are. As a noun, abstraction means the artifacts that result from that process. Those artifacts might be functions, or modules, or classes, or whatever your programming language uses to organize its code. When we create those functions, say, one of the important pieces of abstraction is writing specifications. Specification here as a noun means the intended behavior of the abstraction. We're communicating to other humans what the behavior is supposed to be. As a verb, to specify, that's the act of creating such an artifact, creating a specification. There's two different audiences for specifications, and we write documentation for both audiences, though it's not the same documentation because they have different needs. There are clients and implementers. The clients are the people who are going to consume the specification. Perhaps it's a standard library, for example, and you're the client because you're reading the documentation in the standard library. The implementers are the people who are going to be maintaining the code, or perhaps writing it the first time. These are the people who need to understand maybe more pieces, maybe lower level pieces of the specification than the clients. To a client, a specification tells them what they must guarantee. Guaranteeing this, particularly in terms of functions. I am a help us with what specification means. Specification. Refine that for 500 clarifications.
Oh, I see it. Oh, okay, so this should be like, oh yeah, okay. Damn, that's difficult to catch. Because it's not really an error. And my initial program fixes it. Wait, I think ChatGPT was wrong then, actually. Right? Yeah, this code is wrong. No, it's not. Ah. Oh. So I think we can actually go like this. Here. Maybe it was. I don't know. Hello? Oh my god, I'm... This is difficult. I can't lie. How long is it? It's not supposed to do that, no? No. What? Ah. There we go. Okay. How does this work? They just append, right? Yeah. Why is this not? Since this is placing this behind the Wait, so okay. This makes sense now when I think about it. Sounds right. This will basically, let's say A is like 1, 2. Then we concatenate that with the list, right? Then this fixes a list of flatten L, right? Which is a recursive step. So flatten L will take basically and send the next one. So that's 3. Concatenate that to the next one. Okay. My screen froze earlier, so I'm just making sure that it doesn't happen again. Okay. This, I guess this takes each symbol runs a strategy. Can I go to that somehow? Is this strategy take? So could we have like, I can't. Nope. So could it go like, I mean, I don't know what the strategies are. Take two and list. I can't really tell what this does, not gonna lie. But could it basically go like, strategy take two. This returns a list. Why doesn't this work? Oh, the... Really? Wait, is this just mistyped then? Is moving average here actually in the strategy? Basically, is this the same? Maybe not. Oh yeah, okay. So we can go. So where to get recommendations. I want that, but like built in, you know. I'm guessing this oh, it's actually just this one. There we go. Okay, so it would be like this basically. So these are all in the module strategy, I think. Cool, okay. Oh, I have it bound to control enter, not okay. Taking a function. I don't know what this is. I guess itery. It's on the list, right? Yeah. Because iter is like map, but it doesn't return the result. It only performs the function on each element. So it's basically iterating over the elements. Yeah, okay. Okay, so this is the function, and symbols is the list. And the function takes a symbol and returns the result of run strategy for symbol, symbol, what the fuck is LVT? Hello. What's up, Famish? We're working on a trading bot. Oh, nice. Yeah. Oh, alpaca is... Oh. It's a custom-made API. Okay. Okay. Let's hear. We want the trading bot. I don't care about this. Don't care about this. Why doesn't this work? Wonder why I need to do this. I'm just programming away. Nice. We'll learn programming. Yep, same. Takes time. Just gotta grind away. Nice. Wait, less symbols in something like this? Why is it writing it like this? This is kind of horrible. Run strategy for markets. I've been looking into game dev, seems like a fun way to learn programming. I've never tried it. It seems very fun, I agree. It seems difficult, but it's fun, yeah. Module strategy struct. Just run strategy for markets. Run. Strategi. What's all built already? Module main does not exist. In where? Oh. I guess I need an entry point, maybe. Oh. I don't know, I'm guessing it's just Oh. Bro, I'm doing it correctly. No, I'm not. What do you mean unused? Oh. Well, now it's finding it. Is this just OCaml fucking... There's no with that error. So if we go like this. Bro, I love like optimized. It's so nice, you know? Theme users can't do this. Oh, they probably can. But this, like, OCaml just works, it's quick. Typing works. It's just nice, you know? You can easily jump around stuff. Also, I don't really like how this looks, so I'm going to change it a bit. This still works, right? Okay, I guess if we go like this, maybe. This is nice. Are you allowed to use this? This looks nice to me. I fucking knew it. I felt it. I felt it in my core. But how do I go first? This, there we go. Haha. Okay. I guess it works to go like this as well, right? I guess not. There should be strategy. Trade on change or something. Can we like as market? No. Can it build? What's the difference between int 32 in range and what about float? Float point number between 0 and bound. Inclusive, if bound is negative, the result is negative or 0. This is a complete random float. So can I go like this? If I guess I can go like this. What, didn't need an else block? There's no fucking way. Is this a good way to format it? That's cool, actually. That's cool. Very cool. Let trade equal to random float 1 in match what? Oh, wait, never mind, yeah. No fucking way it got that. Wait, okay, so... Oh, that's even cleaner. You can have like if this and this. Wait, can I go like this? This will be so clean. Or would it be? Maybe not actually. I don't know if I like this or hate this. Okay. I'm gonna call it a day. I feel like I'm getting quite comfortable with OCaml. And that's cool. Quickly, the plan now becomes to basically have a list of markets. So we will basically have this, where this is maybe like president, prime minister, and then we want to trade on news, something like this. I think this is the best way of doing it. So if you have a specific trade, we can have like let market in something like this, I guess. I wonder what this is wrong. Types market. Strategy trade on hop, I guess, doesn't exist, so yeah, okay. Yeah. Cool. We can see. Alright, okay. Got it.